A strip footing is a type of foundation used in building construction to distribute the weight of a structure evenly across the ground. Imagine a long, narrow strip of concrete running along the ground. That's a strip footing. They are typically made of reinforced concrete and are placed at a depth below the frost line to prevent movement due to freezing and thawing of the soil. Strip footings are most commonly used in residential construction for houses and small apartment buildings. They are particularly well suited for structures with load-bearing walls, where the weight of the building is concentrated along specific lines. One of the main reasons strip footings are so common is their simplicity. They are relatively straightforward to design and construct, making them a cost-effective foundation option for many projects. In essence, strip footings act as the unsung heroes of many buildings, providing a stable and reliable base upon which we can build our homes and lives. Designing a strip footing involves careful consideration of several factors to ensure its stability and strength. The primary goal is to distribute the load of the building evenly over a larger area of soil, preventing excessive settlement or movement. One of the most critical factors is determining the load-bearing capacity of the soil. This involves geotechnical investigations to assess the soil's composition, density, and moisture content. The thickness and width of the footing are then calculated based on the load of the structure and the soil's bearing capacity. Reinforcement is crucial to strengthen the concrete and resist tensile stresses caused by the building's weight. Steel bars are strategically placed within the footing to create a mesh-like structure that enhances its ability to withstand bending and cracking. Finally, the choice of materials also plays a role in the design. Concrete is the most commonly used material due to its strength, durability, and availability. The grade of concrete is chosen based on the design requirements. The construction of strip footings involves a systematic process that begins with excavation. The trenches for the footings are dug according to the design specifications, ensuring the correct depth and width. Once the excavation is complete, formwork is built to create the shape of the footing. Formwork is typically made of wood or metal and acts as a mold for the concrete. It ensures that the concrete is poured into the desired shape and size. Before pouring the concrete, steel reinforcement is placed within the formwork according to the design. This reinforcement adds tensile strength to the concrete, preventing cracking and ensuring the footing can withstand the loads imposed by the building. With the reinforcement in place, concrete is poured into the formwork. The concrete is then vibrated to eliminate air bubbles and ensure it flows evenly around the reinforcement. Once the concrete has been poured, it needs time to cure. Curing is crucial for the concrete to gain strength and durability. It involves keeping the concrete moist for a specific period, allowing it to hydrate properly. After curing, the formwork is removed and the strip footing is ready to support the building's weight. Section 4. Advantages of strip footings. Simple, strong, and cost-effective. Strip footings offer several advantages that make them a popular choice for many construction projects. One of their most significant advantages is their cost-effectiveness. Compared to other foundation types, strip footings require less material and labor, making them a budget-friendly option, especially for smaller structures. Another advantage is their simplicity. The design and construction process is relatively straightforward, making them easier to implement, even for less experienced builders. This simplicity also translates to faster construction times, as the excavation, reinforcement, and pouring processes are less complex. In addition to cost and simplicity, strip footings are also highly effective at distributing loads. They spread the weight of the building evenly over a larger area of soil, reducing the risk of settlement and ensuring stability. This is particularly important in areas with weaker soil conditions. Furthermore, strip footings perform well in shallow soil layers. They do not require deep excavations like some other foundation types, making them suitable for sites where the bedrock is closer to the surface. Section 5. Challenges and limitations. When strip footings might not be the best choice, while strip footings offer numerous advantages, they also have limitations that make them unsuitable for certain situations. One limitation is their dependence on stable soil conditions. They are not ideal for areas with highly expansive soils, as the movement of the soil can cause the footing to crack or settle unevenly. Another limitation is their load-bearing capacity. While they are suitable for light to moderate loads, they may not be strong enough for larger, heavier structures. In such cases, other foundation types like mat foundations or pile foundations may be more appropriate. Uneven settlement is also a potential risk with strip footings, especially if the soil conditions are not uniform. If one part of the footing settles more than another, it can lead to cracks in the building's walls or floors. Finally, strip footings have size limitations. They are not practical for very wide or irregularly shaped buildings, as the width required for the footing would become excessive and uneconomical. Choosing the right foundation for your project is a critical decision that depends on various factors. These include the type of soil, the load-bearing requirements, and the design of the structure. Strip footings, with their simplicity, cost-effectiveness, and efficiency in load distribution, are an excellent choice for many projects. However, it's essential to consider their limitations and evaluate if they are suitable for your specific conditions. For larger or more complex structures, alternative foundation types like mat or pile foundations might be more appropriate. Consulting with a structural engineer can provide valuable insights and help you make an informed decision, ensuring the stability and longevity of your construction project.